Okay, ladies and gentlemen, let's take a look here. Not the indeterminate. This is very determinate. Limit. Let's see, they give you this. For x plus 3. Limit as x goes to 1. Now, I mean, I might go back and do some more of those limit laws for you guys, just not today. Just want to share with you guys direct sub. Because what's really going on is that these functions are nice and continuous in some cases at that location. So when I directly sub what? 1 in for x, what happens? Square root 4 times 1 plus 3 gives you square root of what? 7. Okay, so this function's nice and continuous at x is 1, just so you guys know. That's why you can use direct sub. So that's really what's going on, the nitty-gritty of it. But then you might now say to me, okay, Mr. Judge, what about this famous question here? I'm going to say limit as x goes to 0. Okay. X plus 2 to the third power minus 8 over x. And actually, let me do something for you guys. I mean, I could do it this way. No, let's do it this way for now. Okay, let's do it this way. Since we're using that direct sub, what's the story? What's the story here? Wherever there's an x, you're going to plug in what? 0. So you say, okay, this is by direct sub. We get 0 plus 2 cubed minus 8 over what? 0, which means I get 2 cubed minus 8 over 0. Isn't that really 8 minus 8 over 0, which is? Yep, 0 over 0. We say this is indeterminate. All right, you guys okay with that? All right, this thing was indeterminate. Okay, so now you might tell me, well, what do I do now? Because all the other indeterminate questions you had, you just simply what? Factored. Is that true? Well, what do I do here? What kind of algebra do I do now? Okay, now you go, what algebra do I do? Anybody know what I'm talking about? Well, what's the only algebra you can do here? The only algebra you guys can do is called, I mean, you're going to have to just do what? You see this portion up here? What do you think you have to do there? I'm going to try to find a highlighter. Yeah, what is it called? You got to expand that. I think they call it expanding. You go x plus 2 cubed. So, in other words, yes, it's still algebra. I can get the right color. What's x plus 2 cubed minus 8 over x? Well, that's x plus 2 times what? X plus 2 times x plus 2 minus 8. You're going to really do some algebra here. So you're going to have to multiply. That's repeat multiplication. Right here, what do you think that is? X squared plus what? 4x plus 4. Don't forget, you're going to have to multiply that by x plus 2 and then subtract 8 in that numerator, okay? So you might say, well, how do I do that? What I do is you multiply what? X. I don't like that. I'm going to move it out of the way. So you're going to have to multiply x with every term, and then multiply 2 with what? Every term, okay? So do it this way. X cubed plus 4x squared plus 4x. I multiplied x with everything. Now I'm going to multiply 2 with everything. And I'm going to put it under the term that's of the same type. So 2 times x squared is 2x squared. 2 times 4x is what? 8x. And then 2 times 4 is what? 8. And don't forget there's a minus 8 over here. And then everything's over x. So you say, why did I do that? Because I can actually very easily do my arithmetic. Okay, right in here is what I'm saying. You can add these like terms here. And then this is going to be over what? Over x. All right. Doesn't that give me x cubed plus what? 6x squared plus 12x over x? Yep. And then, what do you guys know? I do some more algebra. It's kind of beginning algebra, by the way. You end up with what? X squared plus 6x plus what? Whew. All right, look at all the algebra. Now I got to take the limit as x goes to what? 0. So I had to expand. And what do you guys know? What does this equal? Say that 0 squared, 6 times 0 plus what? 12. Does that equal 12? The answer is what? Yes. So your limit is 12. So I want you guys to get used to doing some algebra here, because we're going to be doing a little bit of this algebra for a while here. All right, you guys okay with that? Just looking at some examples here. So we're starting to do some of those book examples, some more exotic limit questions where you get to use some algebra. I'm looking at my worksheet because I really don't want to do the work on those.
Professor, are we going to have problems where the leading coefficient and the leading term has a coefficient?
Say it again.
Are we going to have problems where the leading term is going to have a coefficient? Like where we have to factor with the... So like let's say instead of x cubed, we have 3x cubed, and then we have to like factor that way.
I'm not sure.
So let's say the problem was 3x cubed plus 6x plus 12.
Okay. Oh, you mean when the leading coefficient is not 1, maybe? Maybe, I don't know. I mean, they can, in theory, give you that. In theory. The point is, you want to remember how to factor. So even if it, and then, let me go back here really quick to my website. You might say, boy, factoring? Yeah, let me go back. You see here, in Math 115, and I'll put that in the chat. You guys see this here? You know, I have videos, worksheets, video solutions for beginning algebra. The whole course, practically. You go, boy, Mr. Judge, maybe Elon Musk will buy my website. Look at that. Special factors? This all predates iPad stuff. I had to use a real camera. It's like it's actually it's not even 720p. It's like 640p. Oh, factoring trinomials. Factoring trinomials where leading coefficient is 1, leading coefficient is 2. I'll even put that here. You go, Mr. Judge, I got to review my factoring. All right. And then I even think, let me double check, because I remember I might have done 245 somewhere. Darn it. There's factoring even in 245. Let me see if I did some of those. What is this? College algebra. I thought I did. Here's some What do I have? I thought I did like the crisscross method. I might even put that on my to-do list somewhere. You guys know the crisscross method? You like the crisscross method of factoring? Yeah, I might even go back and look at that stuff and do another. It's on my to-do list, crisscross method of factoring. That can help a lot of people. I don't know. Maybe I'll do that this weekend. I'll be in Sacramento during some statewide meeting stuff. I'll be in a hotel room. I have these meetings. I'll be at an airport. Maybe I'll kind of consider doing some crisscross method. I don't know. Maybe not, because I can't take all the gear on the airplane. They might think I'm going to take over the airplane. I don't know. So I don't know what I'll do, but the crisscross method, yes. But let's share with you guys a couple of other I want to be careful not to do. All right, let's try this one here. And I'm going to change the variable to h. You go, why did you do that? Because, your book does that. Okay? Just to kind of share with you guys that. So, yeah, I thought I did somewhere the crisscross method. I'd have to dig it out. So remember, by direct substitution here, right? Direct sub, and you plug this in for 0 for h, right? You say, does this give me square root of what? 1 plus 0 minus 1 over what? 0. And then this gives me what? Square root of 1 minus 1 over 0. And that's going to be, oh, again, I get what? Indeterminate. All right. And you go, oh my God, this is indeterminate too. You just got through sharing with me the idea of using what? Algebra. All right. The problem, though, is what kind of algebra are you talking about? And you know what? You can't factor here. Yeah, you can't even expand. You go, what do you mean? There's no, expanding here like you just did, x plus 2 cube. There's no expansion here. You go, what is the deal there? No expansion. And you go, oh my gosh, I'm trying to use algebra here. I don't even know what kind of algebra I can do. Well, that's okay. Because when I took this course and I had to use algebra, I didn't know what algebra to do either. And these problems are all specially chosen. And then people showed, and they showed us here, okay, you're going to use the conjugate. And you go, what? The conjugate. And it's actually technically not a conjugate. You guys know what I mean? It's really not a conjugate. It's conjugate-ish. So you might say, what are you talking about? Well, if you've ever seen, that's a square root minus 1. Conjugates, that whole world of conjugates, is really writing the first radical and changing the sign. Okay? But there's really another radical. So in a real technical sense, you say, is that like the square root of A, square root of B? Yeah, these two things are called conjugates. And they're irrational conjugates. Again, another math course they don't let us teach. Because they say everybody knows it already. Why waste everybody's time? So anyway, those are conjugates. But as you guys know, you got to have two radicals that have really technically a conjugate. You only have one. That's why I call it conjugate what? ish. Okay, so make sure that that's a 1 and that's a 1. And then now you can still put what? You still put this 1 plus h for both. So I want you guys to really see this because it's minus now and that's plus for both of these here. All right, so this is really what it is now, conjugate-ish. Do I have that stuff on my website for intermediate algebra? Well, I got conjugates on my multiply by conjugates, really. But, okay. How does that work? How do you guys multiply fractions again? Do you guys remember? You multiply how? Yeah, and horizontally across, because we always have to be careful by what we mean by across in math. There's diagonal across, there's vertical across, and there's horizontal across. So it's really horizontal. And then you might say, what's the whole benefit of multiplying by conjugates? Well, radicals go away. So by the first term, you get 1 plus h. The O and I terms go away, and the last term is there. So ladies and gentlemen, I'll write down a nice formula for you, but this is the nice effect by multiplying by what? Conjugates. And then what do you guys notice here? In the numerator, don't your 1s go away? And in the denominator, ladies and gentlemen, the h's go away. So this is the nice effect of multiplying by those conjugates here. And now I can take the limit as h goes to 0. This is the algebra you use now. So what does direct substitution do for you now? Say, does that give me now? Plug in 0 for h. 1 over square root 1 plus 0 plus 1 gives you 1 over square root of 1 plus 1. You guys know what that is? Limit to 1/2. Is that right? Yep. So in other words, it's now determined. It's determined to be 1/2. It's no longer indeterminate by using some what? Algebra. No longer indeterminate. We use algebra. This is going to be 1/2. Anyway. So again, you might say, what's the lesson? Well, for some of these questions, the algebra you do is unique. When you have these radicals like you see here, you're not factoring or you're not expanding. You use the conjugate. Just trying to look and make sure I don't do. Let's do some more. Okay, you guys okay with that? And say, what if they give me the limit here? They like using h. There's a very good reason. Okay? So by direct sub, wherever there's an h, you plug in a 0. Okay? By direct sub. So I'll get now 3 plus 0 to the minus 1 minus 3 to the minus 1 over my nice 0. So what do you guys get? You get 3 to the minus 1 minus what? Does anybody happen to know what 3 to the minus 1 actually is? This is 1/3. Okay? So they really give me fractions. So you might even say, you know, could they have given it to me this way? 1 over 3 plus, well, 1 over 3 plus h only. They could have given it to you this way. Okay? Same thing, just so you guys know. And I say, why? Because in your book, they give you questions that kind of look like that too. Anyway, just want to kind of make that familiar for you guys. And obviously, what do you notice now? What is this going to be? What's 1/3 minus 1/3? Isn't that indeterminate? 0 over 0 again? So this is another indeterminate situation. Indeterminate. Oh, okay. So you always want to see with the limit, do your direct sub, because it might be a nice continuous situation. They like to do that. They like to throw some at you and go, you didn't have to do any algebra. All right. But now, if I said to you guys, okay, the fix is to do some algebra up here, right? So what kind of algebra do you guys think you could do here then? You're not factoring. You're not using conjugates. What are you actually looking at here? Focus on the numerator. Because for the denominator, when they say use algebra, they're not even, notice, that's just an H down there. So what kind of algebra can I do for this, numerator? Do you guys know? What do they mean by use algebra there? What do you guys think they mean? I'm saying use some algebra. Well, what are you looking at? A difference of rationals? A difference of fractions with a different denominator? So let me remind you guys. Let's do some algorithm here. Let's give you this algorithm. A over B minus C over D. Do you guys know what that equals? Okay, use this cross. Remember this? This is going to equal what? AD minus BC over what? BD. You're subtracting two unlike fractions. So what does that now give you? 1 times 3 minus 1 times 3 plus h, everything over what? 3 plus h times what? 3. Okay, and don't forget, that's just your numerator. This is all over h. So subtract your fractions. So now you get 3 minus 3 minus h, because you're going to distribute over here, over 3. I'm going to keep this as 3 times 3 plus h. And I'm dividing by what? H. Be careful here. Divide by h. I wrote this how, not vertically, but horizontal. I'm sorry, yeah. Not vertically, but horizontally. And then notice what happens with those 3's. You get negative h, 3 plus h. Now that's times 1 over h. Now, you might start to see a nice pattern here, ladies and gentlemen. What do I mean by that? By seeing a pattern here. What you're going to notice happening every single time is this what? That h is going to cancel. So this is now negative 1 over 3 plus h. You're going to see that cancel. And what's my limit now? H goes to 0. So this is the algebra they have in mind. So by direct sub now, you get negative 1 over 3 plus 0, which is going to equal what? Negative 1/9. All right, you guys okay with that one? Okay, let me give you guys another example here. Limit x goes to 0 from the right, 1 over x minus 1 over the absolute value of x. It's going to be a little bit different here. How is this question different than the ones we've been doing here? Yeah, what stands out is this. Let me get this read out. Be careful. What they really gave you is a nice piecewise function. Okay? Yes, you have to define the absolute value. How? Piecewise. You got to define it in pieces. You got a top piece. You have a what? Bottom what? Piece. Okay? But the question's going to be now, which piece do you use? Remember, if x is greater than or equal to 0, you use the top piece. If x is less than 0, not equal, but less than 0, you use the what? The bottom piece. You guys okay with that? All right. So how do you know which piece you're going to use for that absolute value? Well, you got to know, what's this limit? X is going to 0 from what direction? All right. So if it's going to 0 from the right, which piece do you use? Top or bottom? Why the top? All those values, ladies and gentlemen, to the right of 0 are positive. Is that right? So if they say x is going to 0 from the right, so that means you have to use that top piece. So you're going to replace the absolute value of x with just a what? X. So your limit question is going to be the limit of what? What's 1 minus x minus 1 minus x? You guys know what that is? Isn't that 0? All right. What do you think the limit of that 0 is, that constant function? If I plug in 0 for x, there is no x. I get what? 0. So let me give you guys a fact, because you do need to know some of those limit properties. You can read about it, but I'm going to say the limit as x goes to a of c, where c is a constant, is just the constant. Okay? And even if it's to the right or the left, it doesn't matter, because y is a constant function. You might say, why? Let's give you the detail. Okay, let me show you. Let me sketch the curve. If the constant, you got y is constant here, okay? Or your function is what? C. C is a constant number. This is the graph. Here's A. So if I said, what's the limit as x goes to A from the right and from the what? From the left. Do you guys know? It's that location what? It's the constant. That address is A comma C. Remember, it's always the y coordinate? So this is actually a picture of that property as the limit as x goes to A of any constant is equal to a constant. So that's why we can say 0, limit of 0 is 0. Now, notice this. Maybe this is more interesting. What if you go to 0 from the left. What do you use? What do you use here? Negative x. You use the bottom. You say why? Because if you're going to 0 from the left, all of the numbers for x are negative. Is that right? Numbers to the left of 0 are negative, so you use the bottom. It's a left-handed limit. But what is 1 over x minus 1 over x now? Right in here. You know what that is? It's 1 over x plus 1 over x. What's that going to be? Remember some algebra? 1 plus 1 over x is what? It's 2 over x. Is that right? So here we go. Limit x goes to 0 from, I think I changed it, right? That's now 2 over x. So let's ask you guys, because this is actually a book question, if you guys didn't know. How would you handle this? How would you handle that? Can I ask you guys a question? There's 2 ways to do it. Remember the family of curves every B-STEM student should know? You go, boy, Mr. Judge, you really need to know some of those curves? I think it's helpful. In fact, back in the day, they didn't even let us use a calculator. So as you go to 0 from the left, what does this equal? Negative infinity. Even if that constant is 2, I believe that's the picture. So back in the day, this is what we had to do. We had to go back to those curves every calculus student should know. Can't use a calculator. Jaime Escalante, he was against calculators. Back then, the whole big thing was, calculators anyway. But if you use the calculator, what should you use? Use a negative number that's very, very close to what? 0. To 0. Is that right? So you can go, okay, times have changed. Now that'll be 2 divided by negative 0.000. Get close to what? To 0. Is that kind of close to 0? From the left, because it's negative, right? This is a left-handed limit. So put the negative sign. And you go, Mr. Judge, what is that? You guys know what that is? It's negative 2 followed by what? How many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, what? 10 zeros. You guys know that? Don't put that as an answer, though. What do you guys put? Does that make some sense? It's not negative big. It's actually very small. If that's your checking account balance, you're sad because it's negative. That means you're deeper. It's a kind of small. The further to the left you go or down is small, right? If it's on the y-axis, you're going down forever. You're in a deep hole. If it's on the x-axis, you're going to the left. So the further to the left you go, the smaller the number. It's really a type of small. So that's the limit. It's negative infinity. This is how you handle this, ladies and gentlemen. This is how you do some of those questions. You go, how do they expect me to do this? Well, that's how they expect you to do it. Either the picture or what? Your calculator. All right, you guys okay with that? Now, I'm going to remind you guys, let's go back here. I make the claim, I'll have to find that someday. Thought I did some factoring videos. 261, you say, what am I doing for homework? I highly recommend you working on those what? Homework 1 book questions. So I did some updating for you guys here. I highly recommend you're working on these 2-2 questions, 2-3 questions. You really can do some of these 2-5 questions, believe it or not. Some of them. We're going to continue to do some more, though, on Monday. But I highly recommend you get started on a lot of those and don't wait till when. The last minute and then go, oh, yeah, you guys know what I mean? So I've given you a lot of deep foundation. You could get started on some of these. We'll get more. But even if you said, boy, I'd like to see more of those limit examples, right? I'd like to, oh, let me go back. I messed up. For those at home, I highly recommend you get started on, come on, give me the, I highly recommend you get started on these what? Book questions. You could do a lot of these here. But if you said, I want to see more of those limit question examples, right? Go back down here. What do I have here? For this, these are some examples I did a worksheet for. This is actually one we did, number like 7. I think you even did number 8. Shoot. But there's some more to do, like number 6 and number 9. And, you know, this kind of looks familiar. It's conjugate. Oh, expansion. Oh, factor. Oh, we did this one. Oh, factor. These are the kind of things we did for limit questions. And if you want to see a video on it, just click where? There. Now, I would maybe do more videos on this, but I can't because I'll be in Sacramento discussing blah, 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 blah. Okay. But, ladies and gentlemen, there's some more examples there for you guys. And again, if you need to do a review a little bit of algebra, you go, boy, Mr. Judge, how can I review my factoring and those kind of things? Well, go to Math 115. That way, then you guys have extra examples, right? You got these nice extra examples. Some of these kind of extra examples that are on your what? Yeah. Anyway, so you got some nice extra examples there to look at. Let's do some others though. So you go, oh my gosh, Mr. Judge, you gave me a wealth of examples of limit questions. Okay, so we're going to try to do some of these here. All right, so look at that first one. And I would recommend to you guys how you really want to go about this. Try your direct substitution. Okay, try direct substitution. What do I mean by that? You might have a function that's nice and what? Continuous at that location. So you go, oh, what if I do? I have a nice function that's nice and continuous at that location. What does that equal? Square root of 1 minus what? 1 squared. What does that equal? This is square root of, what's 1 minus 1 squared? Square root of 0 is really what? 0. Okay, you guys okay with that? Now, is that hard to do? No. And why did they put this? Double check here. Does anybody know? Why did they put the limit as x goes to 1 from the right? Why do you think they did that? Yeah, you might say, is it because of the domain of the function? Yeah. You might say, what's in the domain here? Well, remember, any function that has a square root has to be defined in order for you to kind of do some of these things. They're not going to ask you what's the limit as x goes to 5 if it's not even in the domain. You guys know what I mean? They're not going to ask that. And then you might say, where did I learn how to do this domain, right? You guys remember this thing? So, you know, when did you guys learn how to, this is going to be an important detail for us in the calculus course. You know, what do they mean by the domain here? 1 minus x squared, right? Being greater than or equal to 0. What math am I talking about when they're talking domain? Yeah, it's pre-calculus and actually intermediate algebra. So if you said pre-calculus and intermediate algebra, oh, Mr. Judge, you used to teach that course when they let you, back in the times where they felt that people needed this stuff. And now they say everybody knows it. So, okay, this is under sign analysis, by the way. See if I can find it. Oh, nonlinear inequalities, sign analysis. This is going to be a tool that we use. All right, so I'm going to put that in the whatever that is. See the sign analysis stuff? Yeah, it's under nonlinear inequalities. You know, this is kind of the intermediate algebra-ish versions of that. So I'll put that in here for us so you guys know. All right, so just kind of put that little link there. So you might say, boy, I'm going to have to review some of that. Okay, no big deal. There it is. So the domain, it's really a sign analysis kind of question. And moreover, when you go through sign analysis, you will find that the graph of the values of x that are in the domain will be between -1 and what? 1. If I can get a color. Okay, so actually, I think I have it. Do I have it? Do I have it right even? Yeah, I think I have it okay. But what's the problem with this question? I'm noticing an issue here. I think it should be this way. Double check. Is my domain okay? Do you guys know that? Looks like it should be fine. It's fine. This question should be how? You go to one from the left. Why should you have to go from one to the left? Because that function needs to be defined at what? At 1. It's defined at 1, but it also has to be defined to the left of what? 1. Is that true? Anyway. Okay, just giving you guys a little technical detail. Number 2, though, I really want to do number 2. You say, why do you like number 2? This is kind of where we left off, in all honesty. Okay? Kind of where we left off. So if you try to apply direct sub, right, you said, okay, the function might be continuous there. You take the absolute value of 3 minus 3, and then that's over 3 over minus 3. What does that give you? Say, is that absolute value of 0 over 0? And the absolute value of 0 is what?
0.
And then you say, oh, 0 over 0 we know is what? That's indeterminate. Yes. What does indeterminate mean? You can't what? Determine. It means that we don't know what the answer is. So indeterminate means you got to do some what? Algebra. Good job. It means do algebra here.
You have to use a piecewise, right?
Well, yeah, you have to definitely. This is a very common thing where even my daughter, I remember she came to me, Dad, how do you do some of those kind of limit questions with absolute values, right? And I remember saying, okay, Ashley, here's what you do. You define it piecewise. So let's give you guys this fact. Okay, don't know what color, but whatever. Here's a fact you guys always want to do. Okay? The absolute value of anything is what? It's that thing if what you have is greater than or equal to 0. It's opposite that if what you have there is what? Less than 0. Yeah. Oh, I'm sorry. There you go. So this is defined piecewise. So you might say, well, What do you put inside that triangle?
You have to assign like from both sides.
Well, first of all, you see this here? You got two pieces. The top piece and the what? Bottom piece. Okay, so what this means now, let me write it down what it really means here. You say the absolute value of x minus 3 will be x minus 3 if x minus 3 is greater than or equal to 0. It is opposite x minus 3 if x minus 3 is less than 0. Okay? Now, going back to that beginning algebra here, this really means x is greater than or equal to 3, and this means x is less than 3. Okay? So what I'm saying is the top piece is used for values of x that are greater than or equal to 3. The bottom piece is used for values of x that are what? Less than 3. And that's just for your absolute value, for the absolute value only. So then you say, let me be consistent here even with the colors, because I think that's helpful always. Right? And then you say, well, what does that mean about my fraction? This limit is really a two-sided limit. How do you know that limit's really two-sided? How do you know it's a two-sided limit?
Because the 3 doesn't have any like.
It's not like it's not like the last example.
So it's defined for both sides.
It's not like the last example. I mean, I'm going to fix this one. I'm going to remind you guys. That was a two-sided what? Limit. I'm sorry, one-sided limit. This is two-sided because they didn't even what? This one here. Yeah, they didn't give you the direction, so that's what I'm pointing out, that this is a two-sided limit. So when it's a two-sided limit, you might say, oh, what does that mean? That means you got to do two limits for the price of one. You have to say, what's the limit as x goes to 3 from the left? Okay, now let's be careful here. The absolute value of x minus 3 over x minus 3. Now, if you're going to 3 from the left, which piece for the absolute value do you use? Why the green one? Because if you're going to 3 from the left, this is approaching, these are the values of x that are to the left of 3. Is that right? So in green is what I'm saying, is that this is the same as a limit. It's minus x minus 3 over x minus 3. So you're going to need to use that one because those are values of x that are to the left. Now, what happens with the algebra? This is nice. With the algebra, what do you guys see here? Right? Doesn't that cancel?
Yeah.
Limit. X goes to 3 from the left and negative 1. Now, that's a limit of a constant. Negative 1's a constant. What did we say the limit of constants were last time we were here?
The same as
By properties of limits. Did you guys read about that? Properties of limits?
Yeah.
By properties of limits, it's the constant. So this limit equals what?
itself.
Negative 1. The limit of a constant is a constant. So when they give you the absolute value, you're going to need to use this fact, this key here. Let's look at the other limit now. Now, what does this become? Well, you say, well, wait a minute. Which one do I use here? Well, you're approaching 3 now from the what?
Right.
From the right. This was approaching 3 from the left. So the values of x that are to the right of 3, right? Let me find this here. This is going to be to the right now. We use the top function because those x values are to the right of 3. It's x minus 3. So we're going to use that orange part. So it's going to be x minus 3. So here's my point to you. And let's make sure that's to the right there. Okay, anybody have any questions on that? Because that's an extremely important detail. Without that detail, you're not answering the question. You know, without that, you're not answering. So this here, remember, what's x minus 3 over x minus 3? It's 1. So ladies and gentlemen, that's going to be the limit as what? X goes to 3 from the right of 1. The limit of a constant is a what? Constant. So now you have all the information you need, ladies and gentlemen. This is the right-handed limit and the what? Left-handed limit. Because this, they gave you the question as a two-sided question. Okay, if they don't give you the direction, it's two-sided. If they give you the direction, it's only one-sided.
So does not exist.
Well, that's now we have to answer this limit question. Now, we have an answer. This is the algebra they're talking about. Now, you say, I know the answer because these are not the same. Negative 1 is not the same as positive 1. What do you say about this question?
So does not exist.
Does not exist.
Limit does not
Yeah. Does not exist. And just to kind of share with you guys in Desmos, right, y equals x minus 3 divided by x minus 3 here, okay? Now, what you guys see at 3, I mean, you don't see holes because Desmos doesn't put the holes. It doesn't put the dots. It's not open circle, closed circle in Desmos. But at 3, as you guys can see, 3 here, if you said, where is 3? Here we go. And actually, I kind of don't like, I'd rather do it this way. And then here, the dotted line, okay? So as you guys can see, at 3 here, okay, as you approach from the left of 3, the limit is negative 1. Maybe you say, I don't see a negative 1 there. Okay, maybe you see a negative 1 now. As you approach 3 from the left, the limit is negative 1. And as you approach 3 from the right, the limit is positive 1. Left-handed limit is not the same as the right-handed limit. This is a jump discontinuity. Is that right? At what number? 3. So, ladies and gentlemen, and it doesn't show dots and that kind of stuff, but nevertheless, that's the deal. Okay? So that limit does not exist. Now, let's see if you're awake. FYI, because this is an important question too, because we're kind of killing 2 birds with 1 stone. FYI. What's the value of the function at 3? What's f of 3? What's f of 3, ladies and gentlemen? All right, you have the absolute value of x minus 3 over x minus 3. Well, that equals 1 and negative 1 when x is greater than or equal to 3. When x is less than 3. This is, in short, really the function they gave you. And you said, but you just put the absolute value of x minus 3. I know. But the function is really what? This quotient. So you can define the top piecewise, and it's really going to be the whole function being piecewise. Okay? Because remember, this over here is what I'm referring to. See this x greater than or equal to 3? In this definition, you use the top when it equals 3. So that function here, ladies and gentlemen, at 3 is going to equal what? What number? 1. This is really the function. And you say, why? You guys really want to know why? It comes down to the definition of a piecewise function, because that's greater than or what? Or equal. Greater than or equal. That's not strictly greater than. So the limit does not exist around 3, but the value of the function does equal 1. Now, what did we say? Remember, what also they ask you is f continuous at 3? F is discontinuous at x equals 3. Now you say, why? Because the limit, ladies and gentlemen, as x goes to 3 of that function, okay, does not equal f of what? 3. F of 3 is 1, so really on the left, this left side does not exist. That's the limit. And the right side is 1. They're different answers. And that should make sense. You go, why does that make sense? Because you have that thing called a jump discontinuity at x equals 3. You say, what does that mean? If you try to draw that curve at 3, you have to pick up your pencil at 3. And then you continue drawing. So you can't sketch that. So this is putting everything together. These are some book questions, ladies and gentlemen, and like test questions too. They like giving you these kind of questions too on the test. They want to know, do you know what's going on with the curve? Do you know completely what's going on? Not like partly what's going on, not just a little bit. They want you to go all the way. Do you know these ideas? That the limit is not the same as the value of the function. And what is the limit? And obviously, if they have an absolute value, you got to use this fact in your analysis. They also call this analysis, by the way. What is analysis? Analyzing. Complete analysis, not partial. If you go to the doctor with a toothache, you want a complete analysis of the toothache, don't you? Sorry, not a doctor, a dentist. If you go to the doctor with a tummy ache, hopefully you want an analysis of what's going on. Not just part way, not just halfway. What about the next one, number 3? Number 3, is that a two-sided limit or a one-sided limit? How do you know? Huh? They're not given a direction. Is that right? Okay, good. Look at this. There's no direction. You might say, oh, Mr. Judge, what happens when there's no direction? You know what that means? Two-sided limit. So if you said, okay, I'm going to approach this by direct sub, 2 to the 4th minus 16 over what? 2 minus 2 by direct sub. What do you guys end up with? 0 over 0 again, indeterminate form. Darn. All right, no big deal. We just know we have to do what? algebra. Right? Use some what? All right. What kind of algebra can you do, though? What's your algebra? Well, I'm going to start with some special factors. X squared plus 4, x squared minus 4. Do you guys know why I know that? Because this is the numerator is the difference of perfect squares. Beginning algebra. Again, the course they don't let me teach anymore because they say everybody knows this. I'm wasting your time. Or they say if you don't know it, get tutoring. Where's your tutoring lab? Support the students with resources, not courses. So resources that way. All right. X over x minus 2. Okay. Is there another difference of perfect squares? Yes, there is. Good job. See, they're right. You guys do know that. So what is that? The difference of perfect squares is over there. Yeah, let me do this here. X squared plus 4. Now here's another difference. X plus 2, x minus 2 over what? The x minus 2. Cancel, cancel. What do you guys have left? Limit x goes to 2 from the left of x squared plus 4, x plus 2. Okay, so you do have some algebra that can be done here. I've been trying to get the... Now, what could you guys do? Direct sub. Plug that in. What do you think's going to happen? What are you guys going to get there? You're going to get what? 4, isn't that 8 times 4, which is? There you go. Now, that's just the left-handed limit. What about the right-handed limit? You guys know by using the algebra again, isn't that going to be the same algebra? Right? So this is where we use algebra. So you're going to end up with, again, the limit that x goes to 2 over here. X squared plus 4 times x plus 2. And what do you think you're going to get if you do the algebra? Isn't that the same? Oh, man. So, ladies and gentlemen, left-hand limit equals the right-hand limit. What's your conclusion? All right, what's this conclusion? Limit as x goes to 2 of that function. In other words, it's really this. This equals what? 2. Because the left-handed limit equals the what? Right-handed limit. There you go. But ladies and gentlemen, just because the left-handed limit equals the right-handed limit, what's the problem at 2? If I said to you, what does f of 2 equal? What's the problem here? X can't be what? 2. Why can't x can't be 2 here? Yeah, so there's a hole at 2. Just because a function has a limit doesn't mean it's defined. Because the limit is around 2, but at 2 can't never be 2. There's a hole here. So this is where we call that removable discontinuity, because even in Desmos doesn't put holes. Oops, I hit Excel. Desmos doesn't even put holes in things. So if I said, okay, you said, why doesn't Desmos put holes? I guess it just doesn't. So x, and I might even have to put a parenthesis. So x to the what? Fourth power, okay? Minus 16 divided by x minus 2. Now that's in green. I'm going to remove this here. Okay? And I guess at 2, you can't even see, but, you know, this is kind of like a cubic function. Okay? It's like a cubic. Anyway, it doesn't show you holes. You might say, hey, it's nice and continuous. No, it's not actually defined at 2. Anyway, it's right here in Desmos. I don't know if I showed people. And you might say, why? Because right from the original, remember like we've been looking at some of those functions? The removable discontinuities? This is under that removable discontinuity. So you could even say f is, this function is what? What is f? Discontinuous at that point. But it's continuous everywhere else. Because it has that hole, that's 2. And it's the same reason. The limit does not equal the value of the function. So, you know, this is kind of what they're getting at with a lot of these functions. So you did have to do a little bit of some what? Algebra. Number 3. And then what about number 4? Right? Number 4 is interesting as well. Now, let me make sure I even copied it correctly. T squared plus t. I didn't even copy it correctly. That's why I'm like, wait a minute, this is not right. Sorry about that. Let's go back and put the T there. So all of these kind of questions, there's the T. This is a two-sided limit. How do you guys know it's two-sided? Yeah, and let me actually do something here for you guys. I know that you probably don't know this yet, but let me do this here. All right, let's try this together. Let me point something out to you guys, okay? If you said, I know it's a two-sided, let's approach T from the right, because we need both sides. Is that true? Yep. We need both sides. So I'm going to have to approach this from the right and the left. So can I say something to you? Let's do the first one here, okay? I don't know, I guess it's green. What's the limit if I try to approach T from the right here? Do you guys know? This is going to be interesting. Anybody know what that is? So I'm glad we're going over these little details. I'm really glad, because these are the details that kill people. They look at it and they go, oh man, this is not 0 over 0. This is not the indeterminate form I've been used to seeing, like the other examples. This isn't the same. All right, well, let's go through this. Remember, by properties, if they said to you guys, what were some of those properties of limits? I said, take a look at those things, right? If you guys know the limit of what we call a difference of functions, even in my notes, and they arbitrarily put x goes to a. That's found by taking the limit of the functions how? Separately. Okay, this goes back to those properties I said you guys want to take a look at. And this is known as simply saying the limit of a difference is difference of what? Limits. In words, the limit of a difference is difference of limits. So I guess I'm just going to get rid of this. So you might say, what does that mean? Well, that means you're looking at the limit as t goes to 0 from the right of 1 over t minus the limit as t goes to 0 from the right of what? 1 over t squared plus t. Okay. Okay. So what's this first one? And I'm out of colors, and you guys know I'm really. What's this limit? And what's this limit? Do you guys know how to find that limit? What would you say that first limit in orange is? I'm going to say it's infinity. How do we know it's infinity? Anybody know? How do you guys know it's infinity? Can you give me a number to the right of 0 that's close to 0? And plug that in for t. 1 divided by point what? 0, 0, 0, 0, 0. Since it's to the right, doesn't it have to be positive? What is that? Is that a big number? Yeah. Do you guys remember? We went through that. So what's that limit? It's infinity, isn't it? Okay, what about this other limit in green now? So we found the limit here in orange. What's the limit in green? You say, oh, I'm going to do the same thing, okay? But this time it's 1 over parentheses, 0.00001. Square that. And it's really plus the same number, but plus 0.000. How many? 0.001? I don't know if it's the same, but it's really the same number. Pretend it's the same. But what's my point? Is that a big number? Is that a big number too? So what am I saying about this answer? And I think, ladies and gentlemen, those of you guys that couldn't see this calculator at home, this is what I'm showing here numerically. Did you guys have any homework on some of that stuff like that? Yeah. I can see it right away. I can see around the asymptotes, they just ask you for those limit questions. Everybody's like, oh my God, how do I sketch the curve? No, use your calculator. That's what they want you. They want you to do this. And so they want you to go, oh, okay. I mean, they don't want you to go to pre-calculus and ask you to sketch 1 over t squared plus t. Do you guys know what I mean? They don't want you to do that. You may know this sketch because it's those curves every calculus student should know, but they're not exactly asking you to do this sketch really. In those homework questions, they're not. They want you to get close to the asymptote, and can you figure out what's going on numerically? Now, more importantly, you are looking at this very famous picture here of a situation that's very different. You see, this also, infinity minus infinity, is also an indeterminate form. And it turns out that there's other indeterminate forms when you're dealing with limits. They only deal with 2 indeterminate forms for you guys in calculus. 1. Sorry. You're only going to see 0 over 0, and you're going to see infinity minus infinity. I might be wrong by that. I have to think about it. But There's a whole chapter in Calculus 2 on indeterminate forms with limits. There's a whole chapter. Now, could you use Calculus 2 information in Calculus 1?
No.
No. I know you asked. Why not?
Two at once. You can solve some questions just by two steps.
It's not really, how can I put this here? It's a little bit like saying, I'm taking a course in jogging, but you own a golf cart. And you say, Mr. Judge, can I use the golf cart instead of jogging?
I mean, you can.
If you're taking a Calculus 1 course, you need to use the skill sets in Calculus what? 1. This is what we're looking at and studying. This is what we're dealing with. When you get to Calculus 2, you get to do the what? Well, if it's a course now in transportation and not jogging, you guys know what I mean. So this is an indeterminate form. This is what you want to learn. You go, oh, Mr. Judge, that's another indeterminate form? Yeah, I mean, it's in your book. They gave it to you. Infinity minus infinity. All right, now, I just want to give you a quick note on this. Because when you're looking at the left-handed limit of the same question, as you're going to 0 from the right, of the left, of the same question here, okay, you're going to get negative infinity plus infinity. This is the same as what you guys see here. All right? It's an indeterminate form. So they did that. I remember they did that for some of these questions. They go, but I thought it was a 2-sign limit. It is, but you're going to get the same answer for both. I believe so. Just so you guys know. Okay? All right, now back to the original story. If you have an indeterminate form, I'm going to bring out the purple. Bring out the purple. What do we do? Algebra. Thank you. We use, and that's a question, we use algebra. So today I wanted to go over all the gory details. We use algebra. You might say, what kind of algebra can you use on this original question right in here? What's the algebra now? Copy. Yeah, the only algebra you guys really can use, in all honesty, is to subtract those fractions. So here's the algebra. Okay, you may not notice this, but this is 1 over t minus 1 over t plus 1. It's going back to subtracting rationals. I do have some subtracting rational information on my website, blah, 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 blah. But you guys remember how to do that? There's a way to do this. You know what you should do? Of course, you do need the LCM. I'm going to say multiply top and bottom by what? T plus 1, okay? Be a little bit more efficient, because sometimes the price you pay for inefficiency is more algebra later on. So this is going to be t plus 1 over t times t plus 1 minus 1 over t plus 1. Now, what's nice about this? Do you guys know? Yeah. When you have, double check my algebra. When you have the same denominator, you can do the what? Remember this? Yeah, I mean, if you want to see an algorithm, you say, is this a over c minus b over c? Isn't that a minus b over c? And so t plus 1 minus 1, isn't that going to be just what? what do you get? T over t times t plus 1. What happens with your t's? And you just get what? So the algebra, this is going to be now what? 1 over what? T plus 1. Look at that. So now you can say, oh, what's my limit as t goes to 0 from the right of 1 over what? Oh, this is going to be 1 over what? Yes, it's going to be 1. So ladies and gentlemen, this is now determined our determinant. It's going to be 1. And remember I said originally here, if you go the other way, you get negative infinity plus infinity, which is the same. Because I didn't express to you guys really why this is indeterminate, or really why 0 over 0 is indeterminate. Because these are limits. And what's under the hood is what's called a rate in which it goes to these values. So the first limit goes to infinity. The second limit also goes to infinity, but you don't know. One of them may get to infinity faster than the other. And if it does, whatever function wins out, you might have an answer like if the first function goes to infinity faster than the second function, the answer is infinity. If the second function goes to infinity faster, the answer is negative infinity. But they can go at a similar rate where the answer goes to a finite number. In this example, the answer went to a what? Finite number. You know. So there's more to that story about this indeterminate forms. There's also what's called the rate in which it gets there. And it turns out the rate is actually an important detail. Now, you got to pay more fees, take more courses in order to study that portion. It's in what's called an advanced calculus course. You got to finish the calculus sequence and take some other math classes before you get to go back and look at that. But it's not part of calculus 1. The rate of a convergence is not a part of calculus 1.
So what kind of calculus is it?
It's called advanced. Those courses are called advanced calculus.
Do we have that?
Not here. If you major in math, the good news is you get to take that course. And then there's other versions of that, graduate versions too, and blah, blah, blah. In other words, math is its own discipline. It's not a tool that's used by other disciplines. It exists on its own. It's its own entity, but it's treated as just like a service discipline to all the other disciplines, which is sad because that's not what it is. You know, I came back from meetings in Sacramento, and I'll share with you guys what happened. I'm going to put it this way. There was a bill called AB 811 by Mike Fong. He's actually a former trustee at our school, and he's our assembly person in this service area. He's the local assembly person for the college's service area, and I know him. And anyway, he had a bill called AB 811, the repeatability bill. He was trying to give students the opportunity to take courses, to repeat courses for credit. So you might say, why is that a good idea? Well, let's say you took Calculus 1 20 years ago and you got an A or a B or a C, but then you're going to take Calculus 2. You can go straight to Calculus 2. But under this bill, you would be able to repeat Calculus 1 if you made the choice. Not a bad idea. In fact, even if you're a high school student who took Calculus 1 and you got an A, and there's some people like that. I had a trig student last semester. She took Calculus 1. She got an A in Calculus 1. Good for you. But then she said to me, but everybody failed the AP exam. I said, what? What are you talking about? Everybody failed the AP. They all failed. But everybody got an A too. That was in high school. It's a local high school. I won't mention the name of that high school. I don't want to hurt people's feelings because people are delicate these days. You look at people and you hurt their feelings. So let's see, back to the story. I asked the student, how could you guys all fail at this? What are you talking about? The course was taught by Coach. What? It was taught by Coach. What did Coach do? Coach gave everybody an A because it's Coach. And did they do any work? She goes, we didn't do any calculus at all. What? Well, you got an A. So now she was intrigued. What grade do you think she got? She was failing, so she dropped. I don't know where she's at. Anyway, there's a longer story. So, anyway, this bill would have allowed that student to take trig. Now she has to take, actually, she could retake Calculus 1 if she wanted. But that bill would have allowed her to do what? To take trig or pre-calculus or even calculus because it's repeatability. You already got credit for it, so it's going to allow you to retake. Yes. Does that sound like a good idea? So this was going through the legislature, and it was passing. And there was some resistance. There's some special interests out there that don't want you to do this. They don't want you to have that opportunity, folks. There's some nonprofit special interest groups don't want that to happen. And they were resisting it, but they were losing. And then it came to what's called the appropriations. And you want to know? Your governor, Gavin Newsom, he said, if this bill passes, I'm going to veto it. Because he doesn't want to pay for it. Doesn't want, and in fact, it's not just he. There's a whole nonprofit out there that don't want to pay for your, really, for you to take these classes. So they instructed with, CFT, amend the bill, remove math and English, because they wanted to remove it from math and English. It's English too. It's not just math. And otherwise, I'm going to veto it even if it passes, because it was going to go through and pass. So that was my meeting in Sacramento. I was like, what? See, I tried, and I probably shouldn't tell you this story too. I went back and I went to our school and I said, we're going to send a calculus instructor over to that high school to teach that calculus class. You know what our school said? Mm-mm. Why? Because there's something called dual enrollment. We could do that. Why do you think they didn't want to do it?
Pretty tricky or something? Is it like tricky to do it? Like complicated?
No, I mean they're like kids who are in high school. You really don't want to mix, if you can avoid it, high school students with adults. There's real reasons why you don't. You don't want to do that. There's things that can happen. It's kind of an issue. But you can send an instructor over to that school. That can happen. They don't want to do that. It's like, why would you rather have Coach there?
It's cheaper to keep Coach than to pay a calculus instructor.
Actually, no, it'd be under dual enrollment, so you get apportionment for both schools. Get apportionment for it. It's kind of what the state's pushing. The state's pushing this. They're trying to get ninth graders to take college courses throughout the state. It's a whole big thing. There's a whole event here in the summer. I went to that. Anyway, here's the bottom line. You see, that's a little cookie for the coach. It's called a cookie. And then what happens if you start failing all those students? You guys know what I'm saying? You go in there and you wipe the floor. You go, ooh, it's a killing field in there. You start failing everybody. You start doing that, there's a problem. Because these are minors, whatever. That's the real reason. So, you know what the heartbreaking thing is? I have two daughters. Ashley Judge, she majored in math. She took Calculus 1 and 2 in high school, and she went straight to Cal Poly. And she graduated with a math degree, and now she's in a data science master's program for like financial data science or something. I said, okay, Ashley, she's made her choices. I don't push her. I don't really push her. So she's done that. I have another daughter, though. She's 3. So the high school that my daughter would be attending, the 3-year-old, she's not in high school yet, is that same high school. I was like, oh, no, I'm going to be the biggest pain in the parent you could, oh my God. Because this kind of nonsense doesn't happen in every school, ladies and gentlemen. This doesn't fly in every, it will fly around here though. Anyway. So I'm just thinking, because I get to talk to legislators and talk to them. It's not like they listen. And I'm going to say, do I have to move out of my own neighborhood in which I teach? Is I really got to do that to educate my kids? Because this is the quality that's going on in your schools and your service areas. Do the people know this? Because I'm going to tell them. That's now my kids too. If it were your kids, what would you do? These people, legislators. So that was the weekend I had with all of this. You go, what does it have to do with me and math, Mr. Judge? This is the same class. This is the deal. Isn't that interesting? The reality of everything. So, you know, I guess it's just too expensive to educate people, is the message. Gavin Newsom. I did a little homework on Gavin Newsom.
But you didn't take out, right?
Let me say this. I shouldn't say it, but listen. Gavin Newsom has some learning issues. He has some problems, okay? He has problems. He's like Trump in a sense. Can't really read or write or do arithmetic. Like Trump in that way. Was an athlete. Family. The guy's a millionaire, but his family friends with a billionaire. So they kind of hooked him up. In other words, the guy, it seems to me, the writing on the wall is he didn't have the skill sets. He was hooked up for a family relationship. And he did very well for himself. Now, I'm not going to be a hater. I just wish I knew somebody or my family knew people so I could be a millionaire. Because who wants to work as hard as I work? Who wants to put up these videos and go home and I got another meeting and multitasking? And, I got to meet with the state academic senate on the math education and at 3:30 in Zoom to talk about what math skills people need to come out of high school. Oh my God. I got to write this paper and spend my semester or year on this project. Who wants to work? I could have been like Gavin Newsom. If my family only knew the right people, it would have all worked out for me. Could be a millionaire. I should be in Maui right now. Well, I'm sorry, not Maui. I would have probably Kauai. I used to use the Maui phrase. I can't do it anymore. Huh? Yeah, it's horrible. That's a whole other thing. But anyway, that was the weekend. All because of this kind of stuff. All because they say, students don't need this. I go, really? They don't? Well, they should just go get tutoring. Really? You know how hard that is? Who has time? So that's what I have to tell you. That's why I put the resources up, give you extra examples. But that's the story, ladies and gentlemen. Welcome to reality. Where are we at? Oh. What if they ask you the other direction? It's going to be the same. So in other words, the limit as t goes to 0 from the left of 1 over t plus 1, because the algebra was the same. As you plug in that 0, what do you guys get? 1 over 1, which is what? 1. So both directions. Limit t goes to 0. 1 over t plus 1 equals what? 1. And that is the what? That's the lesson. And then that concludes some of the book work I wanted to go over today, ladies and gentlemen, for you guys, because I'm going to link it. I'm putting up more videos. This will be a part of it. So it'll be up there. So I hope Gavin Newsom watches my video. All right, I'll send it to him and say, here, why don't you watch this? You know, we don't all have those family, connections. You know who my family knew, ladies and gentlemen? Nobody. That's why I had to do my homework. That's the way it is. Somebody had a question. Yeah. Yes.
Would we have to solve for the left side as well?
Yes. Yes. When they say, if they didn't give you a direction, you really got to do both.
In this case, they matched up, right?
In this case, they matched up for the same exact reasons. The algebra was the same. Okay, because you're going to get that indeterminate form, infinity minus infinity, or infinity, or negative infinity plus infinity. You're going to get the same, because remember this curve here. If you change direction, remember this thing here? Remember this curve around 0? If you go to 0 from the right, that's positive infinity. If you go to 0 from the left, it's negative infinity. So what I'm saying is this here and this here will be negative infinity, but then so will this one. And you go, Mr. Judge, what does that even mean? What that means is this, okay? You're going to have now negative infinity. What's minus the minus? So negative infinity plus what? Infinity. It's the same. It's really the same indeterminate form.
So anything like infinity plus or minus equals to indeterminate?
Infinity minus infinity is indeterminate. Negative infinity plus infinity is also indeterminate, because the order in which you add doesn't matter.
Oh.
I can switch this order which I add. It's not going to matter. Addition is what's called commutative. But what I'm trying to get at is, notice this. When it's to the right of 0, y goes where? To infinity. When it's to the left of 0, that goes to minus infinity. So by changing the direction, it's exactly the same question as what I'm saying. And since it's the same question, indeterminate, with the same algebra, and remember, when you plug in that 0, it's the same 0. It's not a negative 0 or a positive 0. There's no such thing. But it gives you the same algebra with the same outcome. And that is really what's going on with some of those kind of questions in your book, that it gives you the general direction. And so you do have to look at both. It's a two-sided limit. You have to look at the left and the right. And for a lot of these, it's going to be the same conclusion, in fact. It's going to be for all of them. They're specially chosen, ladies and gentlemen. They are specially chosen. So take a look also at the other examples that I shared with you guys, because again, this is the kind of stuff they say in my whatever it is. Here you go. Where is it? 261. These are the resources I put up here. And it was under limits. Like I said, what I did is I did these from another term, these examples. And I try to stay away from these examples and give you different examples. And they're all from the book. They're kind of bookish examples. So if you said, where do I get to see some of those? Well, it's over here. A mistake. And you're right. So I made a mistake. No, I don't think you're right. But, I mean, you might be right. I'll double check. I haven't double checked that one. You might be. Yeah, there might be. Sometimes there's mistakes on some of the videos there, you know. But anyway, remember going back to this, okay? Remember this question number 2? I want to remark, what x cannot be what number? X minus 3 can't be 0. In other words, the denominator can't be 0. Does that make sense? So what that also means, though, is that x is not 3. Now, it is true, this is the definition that you use for absolute value. This is true. We use this definition right here. And yeah, you want to include when x equals 3 right in here. Okay, so that makes sense. However, when you put it together as a quotient now, what I forgot to mention to people back down in here is what again? Your x value, okay, cannot be the number 3 with the function here, the whole function, okay? So what that means is you can't include 3. You got to fill that out. So even though it's piecewise with the absolute value, but because it's in the form of that quotient there and you could never divide by 3, right? You throw it out. So now you say, what does that mean? That means right in here, f of 3 is going to be what? Undefined. Okay? It's still not continuous, but f of 3 is undefined because you can never divide by 3. All right? You guys okay with that? And I want to mention that in detail. So this is kind of where that mistake was. I'll highlight it even more for you. All right? Just to kind of throw that out there. It's right in here. You know, it's still not continuous at 3, but it's undefined at 3. Okay? I just want to make sure. Oh, let's make sure this is clear too. This is what? Undefined. All righty? All right, and that's where the mistake was, and we're nice and highlighting. It's just like, ladies and gentlemen, it's that removable discontinuity. It's just like the last problem here, like number 3. It's the same logic, by the way. It's undefined at the value, and it's also discontinuous. So anyway, just want to make that clarification.